Math 3, Unit 8, Spring Final Review. This was our unit on statistics. We're going to talk about different sampling methods. So the first one, select any members of the population who are conveniently and readily available. What is that?
Convenience.
Very good.
Wow. That was so hard.
Okay. Number 2, select only members of the population who volunteer for the sample. Very good. The third one, order the population in some way and then select from it at regular intervals. Systematic. Very good. Systematic is correct. And the last one that we're going to talk about, all members of the population are equally likely to be chosen. Random. Very good. So that one we usually call simple random. But if you just said random, that's okay too. Okay. Frito-Lay makes a product called Doritos, which is produced in a factory. The quality inspector of the factory would like to collect a few of the bags produced in the factory to see if the weight of the bag meets the specified amount acceptable by Frito-Lay. The inspector took the next 40 bags on the conveyor belt to inspect. What would we call that? Convenience is correct. Because we're just choosing whatever is closest. We're not taking any random samples or going to different areas. Okay, Ethan obtained an alphabetical list of everyone at his school. He then numbered them from 1 for A and so on. He then got a list of random digits and used the list to obtain his sample. So basically numbers everyone and then randomly gets some people from that list. Very good. Simple random is correct. All right, Tatiana wanted to survey the students at her school. During lunch, she set up a table in the amphitheater and asked her volunteers to complete her survey. She gave them a coupon book as a reward for filling out her survey. Very good. Self-selected is correct. A math teacher wanted to select a sample of students based upon 2 periods of Math 3 classes. The instructor numbered each student starting with 1 and ending with 70. The teacher then decided to take every 10th person wherever he started. Very good. Okay. The next thing we're going to talk about is standard deviation. Standard deviation is the average difference from the mean and measures how spread apart a set of data is. So remember how to find standard deviation? We're going to kind of go through here and look at the symbols. So step 1, calculate the mean or average of the set of data. So remember X bar, that is our mean. You find the mean by taking the sum. So that little E symbol, sigma, it stands for sum. So that means add up all the X values and divide by how many numbers you have. That's how you find the mean. The next step is that you take each piece of data and subtract the mean. Okay, step 3 is you square that value. The next thing is you take the average of all of that new set of data, which gives you the variance. So this right here, that is the variance symbol. And then once you get that value, you take the square root of it to find the standard deviation. So remember that symbol right there stands for standard deviation. Okay, so we're going to use this set of data and go ahead and find the standard deviation. The first thing we have to do is find the mean. And we know that mean stands for X bar, or X bar stands for mean. And we're going to add 1 plus 3 plus 15 plus 17, and you add that together and it equals? Good. And then what do I do with 36? Perfect. And we get? 9. So in order to find our standard deviation, the next thing we do is take each of our pieces of data and subtract it from the mean. So I will go 1 minus 9, 3 minus 9, 15 minus 9, and 17 minus 9. And each of those values there, I get negative 8, negative 6, 6, and 8. Next, we square each of those values. So negative 8 squared is 64. Negative 6 is squared is 36. 6 squared is 36. And 8 squared is 64. Good. Next, we take all of those values and we add them up together, which equals 200. And 200 divided by 4, because there are 4 numbers I added, equals
50.
Very good. 50 is correct. That value right there is our variance. And if you want to write variance next to it, you can. And who remembers how to find the standard deviation? Very good. So in order to find our standard deviation, we take the square root of 50. If you were to break that down, you could have 5 times 10, and 10 breaks down to 5 and 2. So your answer could be written as 5 root 2, or if you just did the square root of 50 in your calculator, it's approximately equal to
7.07.
Excuse me. Good. 7.07 or 7.1. And that is our standard deviation symbol. Any questions there? Okay. Let's go ahead and move on. So continuing talking about standard deviation, it is the spread of data. The more spread out the data is, the larger the standard deviation will be. Which of the following has the larger standard deviation between these two? The one on the left or the one on the right? Which one has a larger? Very good. This has a larger standard deviation. Over here is a smaller standard deviation. This would also be considered normal distribution or symmetrical. This is symmetrical, but it has a larger standard deviation. Okay? All right. Next, we're going to talk about things being skewed. So what do you remember? Is this going to be skewed left or skewed right?
Skewed right.
Very good. Skewed right is correct. So remember that the thinner part, the tail, explains the skewed. So since it's thin on the right, it's skewed right. This one is thin on the left, which means it is very good. This one is normal. And this one over here is none. It is symmetrical, but in this case, they only ask for skewed left, skewed right, normal, and none. So that one would be none. But if symmetrical was a choice, we would choose that. Next, we're going to talk about z-scores. This is our z-score formula. Remember that here, this mu symbol is the same, or similar, we should say, to x bar or the mean. So you could replace that with x bar. As we read through here, it says your class recently took an exam in Math 3 and the average score for the class was 70%. So average score, that's your x bar, is 70. The standard deviation of the class was 8%. So standard deviation is 8%. And then lastly, it goes on to say that you scored, and whenever it's a specific score, specific value that they're giving for someone, that is your x value. And in this case, it's 98%. Determine the z-score. So all we do is plug that information into our formula. So z equals 98 minus 70 divided by 8. 98 minus 70 is what? And 28 divided by 8, if you plug that into your calculator, you get 3.5. So what that means is that the z-score is 3.5 standard deviations from the mean. Any questions there? Okay, the next thing we talked about is the empirical rule. So remember, this one is your 68, 95, 99.7. So when you're looking at this bell curve, normal distribution, here in the middle, this is your mean, or you can also think of it as 0 standard deviations. When you go out, this is 1 standard deviation and -1 standard deviation. Out here, this is 2 standard deviations and -2. And then lastly here, we have 3 standard deviations and -3. When we were working with this in class, we knew that 1 standard deviation was 68% of the data, but it was easier for us to split this up. And so each side here is how many, what percent? Good, this was 34%. Okay, and then, which made, because going out 2 standard deviations was 95%, but this piece right here was actually how much? Do you guys remember? Very good, 13.5% is correct. And then out to 3 standard deviations right here, this piece was what? 2.35% on each side. And then beyond the 3 standard deviations was 0.15%. Okay. And so we also can remember, like you can split it up, but this half, each half is exactly 50% of the data. And the whole bell curve has 100%. So looking at this problem now, and using that information, it states a class just recently took an exam for a math class. The average of the class was 80%. So your average, where there is 0 standard deviations, is right through the middle, and they're saying that that was 80%. Then it goes on to say with a standard deviation of 5%. So what do I do with that 5%? Yeah, so each standard deviation, they're saying that it goes by 5%. So when I go out 1 standard deviation, I'm adding by 5. So that makes this value right here what? Good. 85 and then 90 and 95. And the other direction, we subtract by 5 for each standard deviation, making this 75, 70, and 65. The next thing I would do is go ahead and plug in my numbers in terms of the percents. So we have 34 and 34, 13.5 and 13.5, 2.35 and 2.35, and then the last little piece of 0.15 beyond the 3 standard deviations. Okay, so the first question on A says, what percent of the students received a score of 75 or lower? So we go to the 75, and lower than 75, what will I do? Just add them all up. So that means I have 13.5 plus 2.35 plus 0.15, and you add that all up, and what do you get? 16%. 16% is correct. Another way you could have done that is that you know this is 50, and so if you just did 50 minus 34, that would also give you the 16%. Okay, next. What percent of the students received a score between 70 and 85? So 70 to 85. Very good. So we'd add those up. 34 plus 34 plus 13.5, and it is 81.5%. Last one, if the class was composed of 100 students, how many students would receive a score between 80 and 95? So this one's slightly different. Do you guys remember how to do it?
Yeah.
What would we do?
You would see what percent of the students got that score, and then you, since it's out of 100, that would be your number, but if it wasn't, you would divide the two.
Okay, you're thinking correctly. So you want to first find the percent. So what is the percent of students that are in the range of 80 to 95?
It's 49.85.
So 80 to 95, oops, sorry. You would add those up, right? So 34 plus the 13.5 plus 2.35, and I heard someone say it, it's 49.85%, correct? So then you would multiply by however many people there are. So in this case there's 100, but there could be 500 or 1,000 or whatever. So whatever that number of people or items it is, you take that percent and multiply them together. So in this case, we take 100, but you have to change your percent to a decimal. So what is this percent as a decimal? Good job. So we multiply that together, and we end up getting 49.85. But we don't usually have 0.85 of a person. And so there we would end up just probably rounding that up to be about 50 students.
Also, you can just see that 80 was half and 95 was the max, and that's half of the graph.
Yes, that is true. But let's say that this was like, 700. You would want to understand how to do the exact. But yes, you are correct. Or you could take 700 and divide by 2 or whatever. Okay, any questions?
Is that it?
No, we have one more page. Moving on. Okay, the last thing we're going to talk about is a 5-number summary, box and whisker plot. So while standard deviation is a great way to measure the distribution of data, it should only be used when things are normally distributed. If your data is skewed at all, it's better to use a 5-number summary. Okay, so this is our 5-number summary. Okay, that explains all of that. Hopefully you remember most of that. And then we also talked about outliers. So an outlier is a value that doesn't follow the pattern of the data. And we have to find the interquartile range and your lower boundary and upper boundary in order to check to see if there is an outlier. Outliers are any numbers in the data set that are less than the lower boundary or greater than the upper boundary. So we're going to use our information with this data set here to create a 5-number summary and box and whisker plot. So the first thing you want to do is count how many pieces of data we have. Good. So here there are 10 pieces of data or 10 numbers. Okay. Very obvious is our low value, which is 1, and our high value, which is 25. You also need to make sure that all your numbers are in order, but in this case they were written in order for us. If they weren't, then you would need to change it. Okay, next we have to find the median. What will be my median value? 11, good. Since there are 10 pieces of data, there isn't a middle number, and so you would end up having to take the average of 10 plus 12, and when you do that, you get 11. So that is correct. Your value for Q1 and Q3, they do not include the median. So if there were 11 numbers, our 6th number would be our median, and then all of the data to the left and all the data to the right of that number would be dealing with that here. In this case, the median isn't a value as well. It's 11. And so what is my Q1 value? It's the median of the left side. 8 is correct. And then the median of the right side is your middle number on the right, which is 14 for Q3. You need to check to see if there's any outliers. So we do that by finding the IQR, the interquartile range, which is Q3 minus Q1. And in this case, we have 14 minus 8, which is 6. Then you multiply that number by 1.5. So 6 times 1.5 equals 9. Good. So for your upper boundary, you take your Q3 value, which is 14, and you add 9 to it. And 14 plus 9 is what? 23. If there are any numbers above 23, those are outliers. So do we have any outliers? Yes, this 25 right here is an outlier. Okay, then for your lower boundary, we take the Q1 value, which is 8, and we subtract 9. And 8 minus 9 is -1. Do we have any values smaller than -1? No. So there's no lower boundary outliers. All right, so now we're going to create our box and whisker. When you're creating your box and whisker, if you have an outlier, you're just going to put an X there, and you wouldn't take the whisker to that value. You would take your whisker to the next highest value or the next lowest value. Okay, so I'm going to just mark this by 5s. Okay, so this is 5, 10, 15, 20, 25. Okay, so 25 is an outlier. We're going to make an X there for 25. Our lower value is 1. I forgot to mark here for 0. Our lower value is 1, so we're going to make a point there at 1. Q1 is 8. So I'm going to mark there for 8. We have another, our median is at 11. Q3 is at 14. My high number for my box, though, is going to end up being what?
17.
Good. Okay, and so then we're going to make our boxes with the middle 3 points. And then our whiskers just go out to our low and high number, but again, our high number is not going to be where our outlier is. It's going to be the next highest number. And that's it. That's our box and whisker plot. And just remember that your outlier is still on the graph. It's just not part of the whiskers. Do we have any questions there?